We finally know exactly how long it takes Uranus to turn once. There's a Type 1a supernova in the making, and it's really close. How much total life could be on Titan, and a new comet could brighten in the coming weeks. And in our Space Bites Plus on Patreon, how our understanding of the physical properties of galaxies could be wrong. All these stories and more in this week's Space Bites. How long is a day on a planet? Now, when the planet is a terrestrial world like Mercury or Earth or Mars, you can just watch from above as features on the surface of the planet rotate around and return to the same spot. It's pretty straightforward. But how long is a day on a gas planet, an ice planet like Jupiter or Uranus? And that's really tricky to figure out because the actual clouds are turning at different rates. And so you don't really know, like, which part of the planet are we talking about here? And so the gold standard for figuring out the rotation rate of a planet is to measure the magnetosphere. Even if the clouds are moving around in different ways, the actual magnetosphere turns very predictably with the rotation of the planet. And so this has been measured very accurately at Jupiter, thanks to the Galileo spacecraft, at Saturn, thanks to Cassini, but we've only visited Uranus and Neptune once with the Voyager 2 spacecraft, not long to be able to do long, detailed observations. Voyager 2 made a rough measurement of Uranus's day length at 17 hours, 14 minutes, and 24 seconds when it made its flyby in 1986. But good news, the Hubble Space Telescope has stepped in and given us the most accurate measurement of a day on Uranus so far. 1,000 times more accurate than what Voyager 2 did. And we now know that it is 28 seconds longer than what Voyager 2 measured. So how did they do it? Well, they used an indirect way of looking at the magnetosphere around Uranus. They measured the auroras turning on Uranus, which are generated as the solar wind is interacting with the magnetosphere at Uranus. And so they were able to map out those auroras, and from that they were able to calculate the day length on Uranus. And speaking of Uranus and the Hubble Space Telescope, we have been watching this planet for 20 years now. We have decades of observations, and Uranus takes 84 years to go around the sun. And so 20 years of observations, that works out to be a quarter of its entire orbit. What makes the planet really strange is that it is tilted over right onto its side. And so it is almost like it's rolling sideways around the sun. And so thanks to the Hubble Space Telescope, astronomers have been able to watch as the planet goes from the northern hemisphere going through its spring to moving towards midsummer by 2030. And we can see in the pictures that the polar regions have less methane than the equatorial region. And this is because the methane gives it that pale blue color. And so we've got two stories on Universe Today about Uranus news. That first story was by Mark Thompson, and the second one is by Brian Koberlein. And as always, I will put links in the show notes to all of the references, the stories that we're talking about. A Type 1a supernova in the making. Type 1a supernova are incredibly rare. I mean, we only know of about 2,000 of them so far, but they're incredibly useful. They go off with almost exactly the same amount of intrinsic energy. And so from that, we can calculate their distance. You measure how bright it is, you know how much energy it gave off, that tells you its distance. And this has been used to measure the accelerating expansion rate of the universe. And they are very rare. Over the decades, we've only found a couple of thousand of them. And so the conditions to form a Type 1a supernova have to be exactly right. And we're not 100% sure what goes into this. One possibility is that you have a white dwarf that is feeding on a companion star at just the right flow rate, where it's building up material onto its surface, but not so much that it's able to flush it on a regular basis like a nova does. Instead, it gets to this critical point where it has 1.4 times the mass of the sun, and then it detonates as a supernova. Another way seems to be that you could have two white dwarf stars collide with each other. And then again, you cross that 1.4 times the mass of the sun barrier, and you get this complete explosion of the combined stars. And so now astronomers think they found a precursor to one of these Type 1a supernova, where you have two white dwarf stars orbiting around each other in a binary pair. They take about 14 hours to orbit around each other, and they have a combined mass of 1.56 times the mass of the sun. And that's critical because that gets you above that 1.4 times. I should be saying 1.44, but anyway, because that's the exact number. But anyway, 1.44 rounds down to 1.4, that's fine. And that's the amount of mass that you need to get a Type 1a supernova. And so what astronomers think is going to happen is that at some point in the future, these stars will continue to get closer and closer together. And then at a critical moment, material will start to get siphoned away from one white dwarf star to the other. And now it's on. Once one of them reaches that critical mass, it will have a detonation that starts from the center of it going outward. Then that will explode. That'll hit the remnants of the other white dwarf star, and then the two of them will explode together and the whole thing will be gone, and you'll have a Type 1a supernova. Now here's the scary part. This binary pair is about 150 light years away from us, which is incredibly close for supernova to go off. And when it does go off, it will be 10 times brighter than the full moon. Like when Betelgeuse goes off, it'll be the brightness of the full moon. This will be 10 times brighter. So when's this going to happen, you might ask? Well, not for another 23 billion years. That's how long it's going to take for these two stars to finally spiral inward and then detonate. And of course, the sun will be long gone, the Earth will be cooked, and maybe we'll be in our robot bodies able to watch this really cool event in the far, far future. We've got a great story about that from Mark Thompson on Universe Today. Andromeda's black hole is winking at us. Andromeda is the closest large spiral galaxy to the Milky Way. It's about 2.5 million light years away, and it is headed right for us. And it will merge with the Milky Way in, many billions of years from now. But it has one of the easiest supermassive black holes for us to observe. That's because it is relatively large. It has about 100 million times the mass of the sun. And astronomers have been watching the very center of Andromeda for decades with the Chandra X-ray Observatory. But they've also been looking for bursts of neutrinos that are coming from the direction of Andromeda. And so there are a couple of really interesting flare events that happened, one in 2006, one in 2013, that corresponded to flashes of neutrinos happening at the same time. And so astronomers were able to use the Chandra X-ray Observatory to examine the area around the center of Andromeda, and they had mapped out 4 possible locations where the supermassive black hole is. And then based on the timing, they were able to dial in exactly which of these X-ray hot regions is actually being caused by the supermassive black hole. And we've got more information on that from Mark Thompson on Universe Today. Webb confirms that a planet was swallowed. So back in 2023, astronomers saw a flash in the Zwicky Transient Facility, and this is a all-sky survey that is looking for big changes in brightness. And often these changes in brightness are coming from very short-term events. Like, think of this as like the preview of the Vera Rubin Observatory. And so this one event in 2023 led astronomers to believe that they were watching for the first time a planet be consumed by its star. And they figured there was 2 possible scenarios that were going on here. One is that it was an older red giant star that had expanded up and it had consumed the orbit of a planet that was orbiting close to the star. The other scenario is that the planet had just been orbiting closer and closer to the star and then went in. And so thanks to James Webb, astronomers were able to confirm which of those scenarios it was. What they did was they used James Webb with its incredible resolution to examine the surroundings near this star. And they were able to see that, in fact, it doesn't match a bloated up red giant star. It matches a smaller star that's still in the main sequence stage. And so what they think happened was this planet was probably Jupiter mass. It had started farther away, and over billions of years, it had gotten closer and closer to the star until finally the planet was starting to scrape against the upper atmosphere of the star. And then this caused additional friction, and then the planet went around and around and then got torn up and smeared out along the surface of the star. When that event happened, it caused that brightness that was detected by the Zwicky facility. Supermassive black holes could strip stars down to their helium cores. Now, obviously, we know that black holes can consume stars. They do that all the time. And we see examples of stars getting torn up, going into black holes around the universe. They're also known as tidal disruption events. But astronomers wondered if, you could have a situation where a star could get stripped of its outer gas and still remain star-like and become a compact object in such a way that when it actually collides with a black hole, it produces a gravitational wave. And this is the kind of thing that maybe we could detect. So they simulated a scenario where you have a binary star, two stars orbiting around each other, and they get too close to, say, the supermassive black hole at the heart of the Milky Way. This creates a three-body interaction. One star gets kicked out, probably on an escape trajectory, so it's going to leave the galaxy, and the other one is trapped in orbit around the black hole. It gets closer and closer to the black hole, and the black hole starts to peel away the hydrogen envelope outside of the star, and then just revealing the central helium core. And then this helium core, I'm trying to think what it's like. It's like a white dwarf, but it's just a helium. Anyway, so this helium core is now a very compact object, a fraction of the size of the original star. And it's still orbiting around the black hole, going faster and faster, and then it gets consumed by the black hole in one gulp. And this should generate a kick of gravitational waves. Now, we don't have a gravitational wave observatory that can detect this today, but the upcoming European Space Agency's LISA instrument is hoping to detect a variety of gravitational wave events that are outside of the range of what we can do with LIGO and Virgo and Kagra. And so it could be that LISA would be able to detect these stripped helium cores going into supermassive black holes. And we've got a really interesting story about this by Brian Koberlein on Universe Today. Every week we do a vote on our channel where you tell us what you thought was the best story of the week. And the winner last week was the news about a solar sail mission to Mercury. So thank you everybody who voted. Now I've got an update on that. I just completed the interview with the researcher behind this proposal and it's a banger. So hopefully we'll have that interview for you in a couple of days. But we will be posting the new poll here on the channel into the posts tab within about 24 hours of when you see this video. So if you're just scrolling on YouTube, go ahead and just give us a vote, tell us what you think, and we will celebrate it next week. Now, the best chance is subscribe to the channel, click on the notifications bell, and then train the algorithm that you want to interact with our votes, and then you'll see them forever. There could be life on Titan, but not very much. Titan has all the ingredients for life on its surface. It's got all of these really interesting methane, ethane, it's got amino acids, it's got just all these organic molecules. And then it's got this thick shell of water ice. And then underneath that, you've probably got a liquid ocean of water. And so then the question is, can you make the two get together? Can you somehow get the organic molecules from the surface of Titan down into the water beneath? And so there's got to be cracks and ways that material is getting from the surface down inside Titan. So researchers recently did a bunch of simulations and modeled how this material could get from the surface down into the interior of Titan. And they found that yes, it is indeed possible that there could be some amount of organic material making its way from the surface down into the ocean where it's going to be warm, and then you've got the conditions for life. The problem is that it's not very much, that life in the water in Titan would be starved for organic material. They estimate that you would probably be able to have enough for one cell in every cubic liter of water inside Titan. And does that sound like a lot? Well, they estimate that it is about a few kilograms of total life, like the amount of a small dog. Now, it could be obviously spread out across the entire ocean of Titan, or just one small dog-like creature floating around inside Titan. So, could there be life on Titan? Yes, but it'll be really hard to find. And we've got a story by Mark Thompson on Universe Today. Are exoplanets hiding in dust? Now, if you go out into very dark skies and you take a long exposure picture, if you've set things up right, you can capture an image of the zodiacal dust. This is a bunch of leftover material from the formation of the solar system. And recently, astronomers think actually it might be largely coming from Mars, but you get these small dust particles that are in the plane of the ecliptic where all the planets are going, and you get this almost haze in the sky. It looks like a cloud. And so obviously, if we have zodiacal dust here in the solar system, there's probably zodiacal dust in other solar systems, exozodiacal dust, and that it could be less than what we have here in the solar system, or it could be dramatically more. And of course, dust is the natural enemy of astronomers. And so if you have lots and lots of zodiacal dust in some other planetary system that you're trying to study, it could make it harder and harder to observe the exoplanets that are around those stars. And so we've got a really interesting story on Universe Today by Lawrence Tognetti about how researchers are trying to characterize this exozodiacal dust. And so when that next generation of space telescopes comes online, we'll be able to know where the planets and what's being obscured by dust. And do you really know what you're looking at? Dust. Yeah, there might be a new comet to see in the sky. All right, so it is time for the universe to disappoint us again with a new comet. Like, how many times have I told you there's going to be an exciting new comet in the sky, and then it turns out to be nothing? And so this is probably just going to be another one of those, he says, hedging his bets. But fine, let's just go through the motions. All right. So this comet is called Comet C 2025 F2 Swan, and it was discovered on April 1st. I really don't like where this is going. And you can actually go and see it in the morning sky if you look out to the east before sunrise. So this is a real thing, but it is heading towards the sun, and it's going to go through its perihelion on May 1st. That's the closest point where it gets to the sun. Now, it is 12th magnitude right now, so you can really only see it with a pair of binoculars or a small telescope, but it's expected to brighten up to about 4th magnitude, which is visible with the unaided eye. So maybe, just maybe, probably not, but maybe you'll be able to see a comet in the sky at the beginning of May with your own eyeballs. But come on, the universe has just punished us enough. Why does it do this to us? But if you want to raise your hopes, you can read the story by David Dickinson on Universe Today. Next, let's look at some really cool images. First up, we've got this amazing image of the center of the Milky Way. And the first part of this image shows all of these filaments and then these circular splotches, and the circular splotches are supernova remnants around the center of the Milky Way. And this image, and I'm using this word image, was taken by the Meerkat Radio Observatory. And like, if you've ever seen images taken by radio telescopes, this is not what radio telescopes pictures look like. This is amazing. But then also there's a little inset version where you can see the same region taken by the James Webb Space Telescope. And you can kind of compare what you get between radio emissions and infrared emissions. And I mean, the picture is really cool, especially if you've looked at radio telescope pictures in the past. And yet this is just the very beginning. Like, I wanted to include this image because it's giving us an insight to what the square kilometer array is going to be looking like when they bring online more than 100,000 telescopes covering a square kilometer of surface area in the early 2030s. So hopefully we'll get better and better images from radio telescopes. Next up, this is an image of the star cluster NGC 346, which is in the Small Magellanic Cloud. And this is a picture taken by the Hubble Space Telescope. And this is 200,000 light years away. You know, people in the southern hemisphere can actually see the Small Magellanic Cloud with their own eyeballs. And this star-forming nebula contains about 2,500 stars, and many of them are much bigger and hotter than the sun. All of those blue stars that you can see in this nebula, those are all going to live short lives, detonate as supernova, and then the rest of the stars will scatter into the Small Magellanic Cloud. You're watching this week's Space Bites, and I am writing my weekly email newsletter, The Guide to Space. And we just don't have time to cover all of the stories every week. And so if you want even more stories, we've got a story from Matt Williams about how Perseverance watched a dust devil eat another dust devil. We got a story from Mark Thompson about how a star might have been thrown out of a globular cluster by an intermediate mass black hole. And then we've got a story from Carolyn Collins Peterson about how the solar wind is crashing into Jupiter several times a month and squishing its magnetosphere and causing temperature changes on the planet. Of course, I write every word. It's completely free. There's no ads. You can sign up. Go to universetoday.com/newsletter. Now, you know, I hate ads, and we've tried to remove ads from everywhere that we can, that they'll let us. But YouTube is the one place where we cannot remove ads. We want to show you that we are creating a place where you can watch our videos without ads, and that is over on Patreon. And so we've got a longer version of this exact same video with one extra story. We call that Space Bites Plus. I will put a link in the show notes so you can just click that link and go watch the video over there. It's completely free. You don't have to sign up. It's public, but you'll be able to watch it without any ads and get the extra story. And this week's bonus story is all about how our understanding of the physical properties of galaxies could be wrong. I'll put a link in the show notes so you can click over to Space Bites Plus. I just hit a really big milestone and I will tell you about it in a second. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Bear Lake Roofing, Brian Body, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nelson, David Gilton, and David Matz, Dustin Cable, Evan Pro, Greg Feely, Hans Schultz, Hudson Ward, Jay Graves, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Marcel Smits, Michael Purcell, Modso, Paul Roebuck, Ren Kaidu, Robeck, Sean Sargent, Stanislav Zarajev, Stephen Fowler Munley, Thomas Olskadron, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level, and all our patrons. All your support means universe to us. So I just wrapped up my 1000th interview with a patron. And so a thing that I don't mention on Patreon, but you've probably heard this a couple of times now, is that when you sign up as a patron, you'll get an invitation from me to have an interview. And then you just pick a time from the calendar that works for you. And then we'll hang out for 15 minutes and I'll ask you a bunch of questions about what we do and how we can do better and all that. And I've been doing this for years and years and years. And this week, I've finally crossed the 1000th mark, which is kind of amazing that I've done 1000 of these interviews. So a bunch of you watching this right now have had this interview with me, and a bunch of you are patrons, and maybe you've never had that interview with me. So just like that is always a possibility. It's always an invitation. So reach out if you want to do that interview if you are a patron. And of course, if you're not a patron and you want to hang out and chat with me, become a patron. Go to patreon.com/universe today. All right. We'll see you next week.